Good afternoon, students.
Good afternoon, sir.
Today I will explain Q data structure. Q data structure. This is a Q. Okay. Active learning. So previously I explained stack data structure. Okay. Now I will explain Q data structure. Okay. What is Q? Q is also a linear data structure. Q is also a linear data structure. Previous stack is also a linear data structure. Q is also a linear data structure. Q follows first in first out principle. Q follows stack last in first out. So we will come first, will be gone out first. Q follows FIFO concept. Q follows FIFO. FIFO means first in first out principle. The element inserted at the first is the first element to come out of the list. We will come first, will be gone out first. Okay. The time complexity of the best case is order of 1. Average case is order of 1. Worst case is also order of 1. Set chalgadam order of n. Space it occupies order of n. Okay. Now I will explain Q data structure. This is Q. Q data structure is also a linear data structure. Linear means line. So how to store the data in a linear way? How to store the data in the Q? Linear way. Okay. So Q is also a linear data structure. Now in this case, two ends are there. This is one end. This is another end. In stack have only one end. Insertion and deletion both will happen at one end only in stack. Now Q have insertion at one side, deletion at another side. Insertion at one side, deletion at another side. Okay. Okay. Now, so initially in stack have only insertion deletion both will depends on the top of the stack only. Both will depends on the top of the stack. If you are inserting an element, top will be increased by 1. If you want to delete an element, top is decreased by 1. So coming to the Q data structure, front and rear. Front and okay. If you want to insert an element at rear position means tail. If you want to insert an element at rear position, deletion at front position. Deletion at front position. Initially both are will happen at same position. Initially both are will happen at same position. Front and rear. Okay na? Initially both will happen at same position. Okay. Now we are inserting an element at a rear side. What is the rear? Initially rear at anyone is there in the line? Q లో ఎవరైనా ఉన్నారా? ఇప్పుడు వచ్చారు 10 అనే అతను వచ్చారు, ఈయన వచ్చారు. ఈయన ఎక్కడ స్టోర్ అవుతారు? లైన్లో ఎవరో లేరు, ఎక్కడికి వస్తారు? ఆయనే ఫస్ట్. ఈజ్ ద ఫ్రంట్ పొజిషన్. ఓకే. నౌ rear is moved to increased by 1. Rear is increased by 1. Initially front and rear are same position. So if you want to insert an element into this Q is called NQ. What is the operation? NQ means entering into the Q. NQ means NQ operation. NQ operation means you are inserting an element into the Q is called NQ operation. So now rear is increased by 1. Now rear is here, front is here. Okay. Now I want to insert another element. Okay. Now I want to insert another element. So in this case also we have to check Q is empty or not. Q is empty means then only possible to store the element into the Q. So we can check the rear position. Rear it reaches the maximum size of an array if it is possible to insert an element into the Q. So now rear at which position? One position. What is the size of an Q? 12. 12 means 12 minus 1 means size is 12. size minus 1 is 11. So rare 1, size 11. So Q is empty. So Q is empty means possible to insert an element. Now rare is increased by 1 position. Front is same position. Okay. Now I want to insert another element. Which operation I called? NK operation. First we check the Q is empty or not. Check the rare position. Rare reaches the size minus 1, then only not possible to delete an element. Okay. Now insert 30 and rare is moved to 1 position. Rare plus 1. Okay. Now I am inserting another element. You check and insert element 40. Okay. Now I want to delete an element. A queue line లో ఉన్నారు టికెట్ కోసం, కౌంటర్ ఓపెన్ చేశారు, క్యాష్ పే చేస్తారు, ఫీజు కలెక్షన్. ఫస్ట్ ఎవరు ఉన్నారో వాళ్ళు పే చేసేస్తారు కదా. సో అప్పుడు ఏమవుతుంది, 10 ఇతను వర్క్ అయిపోయింది, కంప్లీట్ అయిపోయింది. డిలీషన్ at which position? Front. సో నౌ ఫ్రంట్ ఈజ్ ఇంక్రీజ్డ్ బై 1. ఇప్పుడు ఎవరు ఫ్రంట్? ఎవరు ఇప్పుడు? ఫస్ట్ ఎలిమెంట్ అతను పని అయిపోయింది. ఇప్పుడు ఫ్రంట్ ఎవరు? 20. So again we can call the DQ. DQ అంటే ఏంటి? Delete an element from the queue. Delete an element from the queue. So DQ call చేస్తే again 10 delete అవుతుంది. Now front is 30. Now we are inserting an element. Insertion at rare. Now rare is increasing. Now we are calling again insertion at rare. Now 30 is the front. Now insertion at we are calling NQ operation, again inserting it line. Now we are calling DQ. DQ means front element is deleted. Now front is 40. Now front is. Now we are inserting another element 80. Now rare is increased by 1. Now we are calling NQ operation. Again we are calling NQ operation means check the Q is empty or not. Q is empty, increased by 1 rare. Now we are calling DQ operation. DQ means deleting. So 40 is deleted. Now 50 is front position. Now 50 is front position. Now again we are calling the DQ operation. So 50 is deleted. Now front is 60. Now we are inserting another element 100. Rare is this position. Now we are calling DQ operation, deletion from the front. Now we are calling insert position. Now rare at which position? What is the rare position? 11. Now we are calling the NQ operation. Now we are calling the NQ operation. What will happen? Rare reaches the size minus 1. Rare reaches the size minus 1 means Q is full. So Q is full means it is not possible to insert an element into the queue. Okay. Now we are calling DQ operation. 70 is deleted. Now head is 80 front. Now we are calling front position. DQ. Front element is deleted. Again front reaches the 100. Now again calling the DQ. 100 is deleted. Now front is 110. Now we are calling DQ. 110 is also deleted. Again rear and front are both are same position. Okay, this is the Q data structure. This is the Q data structure. But what will happen? What is the major drawback in this queue? Actually we are deleting front side elements, na? Okay, we are inserting 120. It shows Q is full. It shows, but Q is full. Q is full. Q is full. Any element is there in the queue. But what will happen? Rare it reaches the level. To understand Q is full. So to overcome this problem, circular queue. To overcome this problem, సర్క్యులర్ క్యూ. ఎప్పుడైతే మనం సర్క్యులర్ క్యూని ఇచ్చేస్తామో అప్పుడు ఏమవుతుంది, ఈ ప్రాబ్లం సాల్వ్ అవుతుంది. స్టాక్లో మనం ఎక్కడ మెమరీ లాస్ అవ్వట్లేదు. స్టాక్ ఇన్సర్షన్ డిలీషన్ బోత్ విల్ హ్యాపెన్ సేమ్ సైడ్ కాబట్టి సైజ్ ఉంటే పెడుతున్నాం, లేదంటే లేదు. ఇక్కడ స్పేస్ ఉండి కూడా ఇన్సర్షన్ చేయడానికి కుదరట్లే. ఎందుకని ఇన్సర్షన్ ఎట్ రేర్ సైడ్, డిలీషన్ ఎట్ ఫ్రంట్ సైడ్ చేయడం వల్ల దీనికి కమ్యూనికేషన్ కుదరగా ఇది రేర్ రీచ్ వెంటనే క్యూ ఈజ్ ఫుల్ అని చెప్పేస్తుంది. బట్ క్యూ ఎవరన్నా ఉన్నారు ఇందులో లేరు. అది ఎప్పుడైతే మనం సర్క్యులర్ చేసామనుకోండి ఏమవుతుంది, సర్క్యులర్ చేసామనుకోండి ఏమవుతుంది చూడండి. ఫర్ ఎగ్జాంపుల్ 20, 40, 50, 60, 70, 80, 90, 100 or 10 ఉన్నాయి అనుకుందాం ఫర్ ఎగ్జాంపుల్. ఓకే, దిస్ ఈజ్ ఫ్రంట్, దిస్ ఈజ్ రేర్. ఫర్ ఎగ్జాంపుల్ సర్క్యులర్ క్యూ చేసాం అనుకోండి, ఇప్పుడు ఏమవుతుంది, ఫ్రంట్ డిలీట్ చేస్తున్నాం. అప్పుడు ఏం చేస్తాం, సర్క్యులర్ క్యూ అంటే వీళ్ళందరూ ఫ్రంట్కి మూవ్ అవుతారు. అప్పుడు సైజ్ ఉంటుందా మళ్ళీ? సో అగైన్ ఫ్రంట్ డిలీట్ చేసాం. సర్క్యులర్ క్యూ ఇలా జరిగినప్పుడు మళ్ళీ స్పేస్ ఉంటుందా? సో టు ఓవర్కమ్ దిస్ ప్రాబ్లమ్ త్రూ circular queue model. To overcome this problem through circular queue. Okay, so queue is also a linear data structure. Queue is also a linear data structure. Queue follows first in first out principle. Who will came first will be gone out first. Okay, queue data structure follows FIFO principle. If you want to insert an element into the queue is called NQ operation. If you want to delete an element from the queue is called DQ operation. Okay, so if you want to insertion at rear side, back side, deletion at front side. Okay, deletion at front side. These are the applications of the queue data structures. CPU scheduling. What is CPU? Central processing unit in the computer. CPU scheduling, multi-programming, disk scheduling, mail queues, handling website traffic. All these applications are queue applications, sir. These are the few applications of queue data structure. Okay, thank you.